Okay, let's talk about something that happens to all of us. That moment when you're trying to learn something and your brain just hits a wall. Well, there's a name for that. It's called cognitive load theory. And honestly, understanding this is a total game changer for learning faster and teaching way more effectively.
You know exactly what I'm talking about, right? You're trying to wrap your head around a new concept, and suddenly, poof, nothing. It feels like your brain is a cup that's already full, and any new information just spills right over the edge. It's frustrating.
But here's the good news. It is not because you're not smart enough, not at all. It's actually a design feature of the human brain. And it all comes down to this one critical bottleneck in the system. And once you see it, you can't unsee it. So first, let's just put a name on this feeling, this common frustration. We're talking about cognitive overload. This is the core problem right here. Cognitive overload is when your brain is just completely swamped. Think of it like a massive traffic jam on your mental highway. Everything grinds to a halt. You can't learn anything new, and you can't even make good decisions. And trust me, it happens to everybody. So why? Why does our brain have this vulnerability? Well, the answer is in the architecture of our memory. Specifically, it's all about that bottleneck I mentioned. Okay, so just imagine your brain works kind of like a computer. First, you've got your sensory memory. It's this giant filter taking in millions of bits of data from the world, but only passing the important stuff along. That important stuff goes to stage two, working memory. This is where you actually think and process things. And then finally, if all goes well, that information gets filed away in your huge, vast, long-term memory. And that brings us to the star of the show, or maybe the villain, your working memory. I want you to think of it like a tiny little workbench. It's where you actively tinker with new ideas. But here is the catch, and it's a huge one. That workbench is shockingly small.
Yep, that's it. 5 to 9. At any given moment, your conscious brain can only juggle about 5 to 9 new pieces of information. We call them chunks. Any more than that, and stuff just starts clattering to the floor. This tiny capacity, this is the bottleneck.
So you're probably thinking, wait, how do we learn anything complex then? Well, the secret is all about using that massive long-term memory of ours. We bundle information into these organized patterns called schemas. Think about learning to drive. At first, you're juggling all these separate chunks, right? The wheel, the pedals, the mirrors, the blinker, it's a lot. But after a while, it all collapses into one single schema called driving, and that only takes up one slot on your workbench. See how that works? Okay, so to really master this, we have to understand what's taking up all the space on that little workbench. Cognitive load theory says there are 3 different loads, all fighting for your brain's precious, limited resources. All right, let's break them down. First, you've got intrinsic load. This is just how hard the topic is, period. Learning your ABCs has a low intrinsic load. Learning astrophysics, well, that has a really high one. You can't really change it, you just have to manage it. Then you have extraneous load. Now this one is the villain of our story. This is the bad load. It's all the mental energy you waste on confusing instructions, cluttered slides, or irrelevant fluff. Our goal? Eliminate this. And finally, there's germane load. This is the good stuff. This is the deep thinking, the aha moments, the actual effort of building those powerful schemas. We want to maximize this as much as possible. And really, it all comes down to this simple, elegant formula. If the difficulty of the topic, plus the confusing presentation, plus the effort to learn it, is more than your tiny workbench can handle, you get overload. Game over. Learning stops. And since we can't really change how hard a topic is, our single biggest point of leverage is to ruthlessly cut out that extraneous, bad load. Okay, theory is great, but let's make this real. What does this actually look like out in the wild? We're going to look at a few examples from medical education where this stuff is absolutely critical. This is a perfect example. Look at the slide on the left. Whoa, it's a total mess, right? Your brain has no idea where to even start looking. That is high extraneous load, just pure confusion. But now, look at the one on the right. So much smarter. It starts simple, points to just one thing, and then it slowly builds from there. By killing the clutter, it frees up all that mental space for actual learning. Or how about a clinical case? The intrinsic load is already high. This is a complicated medical issue. But if you throw in a bunch of irrelevant details in the case file, you're just piling on useless extraneous load. The good stuff, the germane load, is when a great teacher steps in and helps the student connect the important dots, guiding them as they build that critical diagnostic schema in their mind. Oh, and this technique is a powerhouse. It's called a worked example. Instead of just saying, okay, go figure out CPR, you show them a perfect demonstration first. This completely removes all the guesswork and confusion. That's the extraneous load. And it lets the learner pour all their mental energy into understanding the correct procedure.
So we've seen the problem, we understand the cause, we've looked at real-world examples. Let's bring it all home. How do we actually use this to design better learning experiences?
Here are the big takeaways. Number 1, get rid of everything that isn't absolutely essential. Be a ruthless editor. 2, don't try to teach the whole thing at once. Break big ideas down into smaller, bite-sized pieces. 3, show, don't just tell. Use those worked examples. And 4, make it easy for the brain. Put labels right on the image instead of in a separate key. And try to present info using both visuals and audio, because they use different channels in your working memory, which helps a lot. Ultimately, this is what it all comes down to. Good teaching and good communication isn't about sounding smart. It's about closing the gap between what someone knows right now and what they need to know without overwhelming them. You're building them a bridge, not asking them to jump across a giant canyon.
And so I'll leave you with this question. The next time you have to explain something, whether it's in a big presentation, a simple email, or just talking to a friend, how are you going to cut out that bad load, all that clutter, to make more room for what actually matters, real, genuine understanding? Thanks so much for digging into this with me.